Okay. So over the last 2 hours, again, everyone who's watching this live, thank you very much for joining us. If it's the first time you've joined us today, I'm Roger Struckoff, the conference chair. We have a lot of people in the room here who, over the last 2 hours, first they heard that everything you know about blockchain is wrong, and then they heard that everything you know about the cloud is wrong, and you need to learn. So our next, with that build-up, I'll introduce our next speaker, if the siren ever stops in the background. I guess we must be in New York, right? Our next speaker is David Linthicum. He's with Deloitte now, but he has a very distinguished history as a writer, analyst, commentator, many other things. We're really glad to have him here, and that's all I'm going to say. Let's let David do the talking. David Linthicum.
Well, thank you, George. And I just want to say everything you heard about serverless so far is wrong. I'm here to tell you, set you straight. So let's talk about this technology and kind of what it means to you if you're, either a cloud architect or a cloud professional, or you're participating in some sort of a tactical way, or you're just looking at the cloud as really kind of as the next generation platform for your technology. And so ultimately, there's some good and bad aspects of dealing with serverless technology. reInvent's going to happen in a couple of weeks, and though I have no insight into what AWS is going to announce, chances are it's going to be serverless database technology, serverless everything, in terms of people just kind of moving in this direction. And if you think about this, it's really, you can start the clock anytime. And you think about this, it's really a matter of basically looking at how how we're going to allocate resources moving forward. And one of the things when I first got into cloud, and I've been in cloud computing a long time, it was almost like setting up a virtual data center when I wanted to allocate storage resources, compute resources, things like that to set up. So I had to think well ahead in terms of the resources that I needed. And so if I'm going to build applications or going to migrate applications to the cloud, that they had to have the capability of, in essence, running on the resources that I'm allocating. And there's really no way to dynamically allocate the things, and I had to go back out and reconfigure and reconstruct the servers, virtually of course, because it's in the cloud, to allow itself to run the particular application workloads that I was running. And meanwhile, on the PaaS side of the house, platform as a service, those guys really kind of had it figured out. You wouldn't go ahead and run your applications, and basically it allocates the server resources you need, the database resources you need. You're just kind of in a sandbox and very limited to what you can hook up to, where the infrastructure as a service environments were typically more complex, but therefore they also provided more platform analogs that you needed. PaaS providers allowed you quicker time to deployment. So when we look at the serverless capabilities, we're really kind of marrying what the good ideas of PaaS were in terms of leveraging infrastructure as a service resources with the ability to kind of abstract the developers away from having to deal with the physical server issues that we've been dealing with for the last 30 years. And so moving into cloud, we could deal with them in a virtual way, but we're still dealing with them. Now we don't have to deal with them in a virtual way. We can basically assign that task to the cloud providers, but there's some trade-offs in doing that, and we'll go through those during the presentation. First, let's back up and understand cloud. How many people were in cloud computing back in 2008, 10 years ago? A couple of hands go up. Remember that all we talked about then was OpEx versus CapEx, and the ability to kind of think in terms of the operational savings that we're going to have for cloud. And here we are 10 years later, and the thinking sort of changed. In fact, while I can always save somebody 20, 30% in operational costs, typically over their on-premise systems, the value of cloud is really something that's completely different. So it's about speed to deploy, the ability to allocate resources as you need them, scale them up to, in essence, allow yourself to take advantage of whatever you need to solve the problem, and speed to change, the ability to change those resources around business needs change. We buy a company, remove a company, we add a product line, we delete a product line, something that can take as much as a year or 2 years today in a lot of the bigger companies. And then finally, the speed to fail, which is, the typical dribble you hear out of Silicon Valley that we need to fail fast, fail fast, fail fast. But your ability to, in essence, go out there and experiment and innovate ultimately becomes the real value of cloud computing. I just wrote a blog that I just filed, and you'll be reading on Deloitte.com in a couple, 3 weeks, called The Brand Apocalypse. Basically, we're looking at the changing of the brands. In other words, over the next 10 years, a lot of the brands that we're dealing with as household words that we deal with all the time, automobile manufacturers, people who are making food, people who are selling gasoline, energy, healthcare things. A lot of those things are going to go away. And I think the reason they're going to go away is because a lot of the disruptors in the space, the eBays of the world, the Ubers, the Netflixes, the Amazon.coms, now have the ability to punch way above their weight with better technology and are leveraging that as kind of a force multiplier against the larger guys. And we're seeing that kind of in a stealth mode now, where we're seeing certainly the disruption we just talked about with the Amazons, the Ubers, and the eBays, those sorts of things. But we're seeing lots of smaller companies enter the space of insurance and finance and banking and manufacturing and automobile production and things like that. Some of them very obvious and kind of household brands unto themselves. These are the disruptors, guys like Tesla. Some of them are not so obvious. You haven't heard of them yet, but in the next few years you will hear of them. And then we're going to go through a disruption in the large brand space where a lot of these things are going to fall by the wayside, not because they did anything wrong, but because they weren't able to change as quickly as their market was changing internal to the company. So there's not a culture of innovation, a culture of change, a culture of accepting experimentation, ultimately failure. So the ability to fail fast, is not only just some kitschy word that comes out of Silicon Valley. It really is truly how people are going to innovate in this space, and they're leveraging cloud computing and all the features and functions of cloud computing, AI technology, machine learning technology, things like that, as a force multiplier to, in essence, allow us to go out there and attack the folks you're competing with or attack a market you're looking to go after. Just ask the New York Taxi Association now how it's going now that Uber's here, or ask the hotel suppliers how Airbnb is affecting their booking rates. So the perceived value is speed to fail, speed to change, speed to deployment. Ops cost savings is still in the perception. That's just not the reality. And so I always get a little nervous if I'm going to go talk to a client and they're looking for the 20-30% operational cost savings, in some cases to pay for the cloud movement. So I always like this zero-sum game that people are looking to play where we're going to go ahead and move to cloud and we're going to pay for the movement to cloud based on the operational cost savings, which we view as significant. And they will get operational cost savings, but if you're unwilling to look at this technology as strategic changes that you're making to your organization to allow us to become faster, better, and more agile, then you're not necessarily getting to the value we're looking to do. In fact, I would say I get a little nervous when they have that perception. And if I'm able to change the perception, I think they're ultimately going to be disappointed by cloud because they're looking toward the wrong metrics to kind of measure the utilization of this technology. And it's game-changing, but it's a systemic, expensive, disruptive change that'll affect pretty much everybody in the organization, and they have to get all in terms of how the culture is going to get changed and moving in this direction. So the true value, speed to fail, speed to change, really is where the value comes in. So we're finding that if I'm able to do particular metrics for a particular client, that we can measure the value that comes out of the agility aspect of it or the speed to deploy aspect of it as kind of a core metric that's going to go directly to the bottom line. But it's not necessarily the perception that we see, very different than the true value. So speed to deployment and operational cost savings, while there, based on the risk and the challenges that cloud computing can bring, it's not easy to start moving 50% of your application workloads over to cloud computing, let alone 70%, let alone 80%, getting to the point of saturation where it doesn't make sense to move the other applications over. In any easy way, it's going to drag risk. It's going to cost you typically more than you anticipate. It's going to take a long time to migrate, and we find that a lot of architectures in the existing enterprise space need a lot of work just to make them viable on cloud. They have to be refactored to make them cloud native. They have to be changing their infrastructure, change their databases, things like that. And so the amount of work that has to occur to move into cloud means that the operational cost savings are typically not going to be significant enough to really kind of move the needle in terms of what this technology is able to do. However, the agility aspect of it will be significant enough. And the value that comes to you as an organization is really going to be dependent on what kind of organization you are. If you're a tire manufacturing plant, in Iowa, and your processes haven't changed in the last 50 years, and you don't intend on changing your processes, you're going to get very little value from agility and the ability to speed your failures. However, if you're a finance company, a high-tech company, a bank, an insurance company, where you are going to get a premium based on your ability to be agile and your ability to scale, then it's going to have a much higher multiplier in terms of what that's able to provide you. So everybody's going to be different in terms of the value you're able to get from this technology. Everybody's going to leverage this technology in a different way. So no longer do we have to think about server resources when building and deploying applications. That's kind of the core message for what we're looking to do. And if you think about it, serverless really it's a nice buzzword, and everybody seems to be moving after this particular shiny objects, as well as container-based computing and machine learning and big data in the cloud and all these things we're hearing about. But it's really kind of a no-brainer in terms of how cloud computing should evolve. Many of the cloud pundits that are around back in 2006, 2007, when the cloud buzzword started to first arrive, we were leveraging some of the first instances of cloud computing, rightfully so, were complaining about the static nature of those instances and your ability to have to turn them on and turn them off. And by the way, if you forget to turn them off, you could get a nice big bill at the end of the month. I've did that a few times where I had to do tutorials or demos for lynda.com, and I get a cloud computing account up and running. I forget to deallocate the servers after I do the course, and then I get a nice bill for $1,000 at the end of the month, which is, you can't really do much about. But the reality is I didn't need to keep those servers up and running, and the cloud provider, should have realized if I wasn't storing those services or accessing the services, should have deallocated those resources. Well, serverless kind of gets a little bit more common sense into the various systems. So we have traditional servers versus serverless, and the ability to, in essence, save costs and basically provide us with the ability to deal with things as we would like to deal with things as basic utility. So if you think about it, cloud computing has always called itself a utility and basically aligned itself with a power plant or a water plant. But the reality is we don't just pay for what we use, we pay for what we go ahead and set up and we deploy. And so if we forget to not deploy it, if we're not utilizing as much as we thought we would, we still have to pay the bill. It's almost like an electric company, sending you the price of a generator that you went ahead and allocated, but you only use half the capacity of the generator, but you're still paying for the whole generator, versus a utility company doing what utility companies do. They meter you and they only make you pay for the particular instance that you use. And that's often a big surprise for people who get into cloud. It's almost like you're taken back by the unsophistication of how we're dealing with this infrastructure. Well, serverless in essence solves that problem. So we're not dealing with the notion of having to provision some type of server, for our operational cloud-based platforms. And the reason we're taking the term serverless into application development is because when we dealt with application development, that's probably the most laborious thing to do. You basically had to figure out and calculate, sometimes with formulas, and deal with the calculators that are on the particular cloud providers, with how much of a storage resource you need, how much of a compute resource you need, how much of a memory impact resource you need, and how you're able to, in essence, allocate this technology to meet the needs of the application. And by the way, if the application changes its needs, you have to go out there and reconfigure it. And by the way, you have to optimize and tune for the particular application. And that was something you typically got wrong most of the time. And whether the guidance was getting better, and certainly the courses that you can take from Amazon and Microsoft and Google in terms of how to configure this technology are pretty good. The reality is you're kind of guessing, unless you have a core meter perception in terms of how much capacity that you need. So you're always going to be neglectful or not optimizing the virtual technology that you're leveraging, even though the cloud provider itself is going to optimize that for you. And so in other words, if you're not leveraging a storage system, you're able to allocate additional storage as you need it, via the application, but they're going to take that storage and basically, leverage it in a multi-tenant environment and push those resources off to other things. So what you don't leverage, they leverage for you, but you're still paying for it. That's kind of how it works in a multi-tenant world. So we don't get away from servers. That's the whole thing with serverless is obviously servers are still innate to the process. We're just managing servers in a different way. In fact, I was going to give this an accurate name. This would be called managed serverless, or no servers to manage, or no server ops. That's kind of a better way to depict it. But we're still dealing with servers. When I teach classes on serverless technology, that becomes kind of a core thing. We're still dealing with storage, still dealing with databases, still dealing with things that we're allocating and moving into these systems. So the continuous scaling aspect is probably the most important thing. The reconfigure, but the ability for it to auto-scale in a true way, based on the behavior of the application, allocating the resources that you need, and this is across all the clouds. I'm creating kind of an amalgam of Amazon, Microsoft, and Google are basically doing the same thing. So no longer do I have to sit down and do some scaling algorithms in terms of how much capacity that I need that I'm typically getting guessed wrong at. And the reality is developers act like developers do, and back in the day when I needed to allocate physical servers down in the data center, I always overbought because I knew that the capacity was going to be needed in the next couple of years, and I didn't want to have to go through a 2 to 3 month procurement cycle again to get those resources in place. So the ability to not only provide auto scaling, to provide scaling for your applications to the point you can get 10,000 users on the thing in an instance of time, but the ability to do so in a way that's automatic, and the ability to kind of descale down and only pay for the server's resources you're able to leverage really is kind of a neat trick, something that we would thought that the cloud computing world would have done 10 years ago when they created the technology, but they're able to do it right now. So you have to think about how many servers to allocate, you have to think about how many users align to server allocations, and all these sizing things kind of go out the window, which used to drive me nuts because basically they never were correct because we make assumptions that weren't correct. We made assumptions by number of users, by by capacity, by amount of data that we think we're going to load onto the systems. But the reality is they're just assumptions. We're always going to overestimate and therefore allocate too many resources that are allocated to a particular application, or we're going to underallocate, which is worse, meaning that during Christmas time, if you're a retail organization, suddenly people are going to get turned away from the website because the inventory capacity is exceeding the capacity of the particular cloud service that you leveraged. So, and the other thing is you never pay for idle, which is, I told you, the $1,000 bill I got for leveraging an AWS storage bucket, for a certain amount of time, but I left it on. It's fair. So I was allocating resources on their cloud. I was to pay for those resources, and there I got the bill for the resources and had to pay for the resources. But the idea of every time that we're leveraging a cloud provider, having to have utilities like the Symbian Army and other things to basically go out there and deal with the zombie processes and things that we're not leveraging, and that onus being on us, I always thought was kind of ridiculous. And the reality is, if you're dealing with a DevOps organization where you can have hundreds of people that are building the same application, leveraging the same infrastructure, you're always going to find instances where things are going to be allocated and not deallocated, even though people have a tendency to take a pretty close eye on that stuff right now, and there's lots of utilities to find those things and kill them. But we're still at maybe 50% efficiency with what's allocated on the cloud, so therefore we're spending 50% more money than we need to spend, which is over-optimized for the particular applications that we're leveraging. So this kind of gets you out of that horrible job of running around yelling at people for having servers allocated and storage allocated and databases allocated that the company's paying for. I just got an email the other week. I had a couple of instances and things that were running on a particular cloud provider, and someone was able to find it and point it out to me, and thank God, or else I would get another $1,000 bill at the end of the month. And all these things are basically part of living with cloud today. So now the good news and the bad news is how you leverage this technology. Well, let me give you the bad news first, which I'm probably going to talk about in another slide, but I might as well get it out of the way. It's portability. And so the notion that we're going to optimize a application workload for a serverless environment means by default it's typically not going to be as portable. So the idea that we're going to write an application once on a particular serverless environment and push it over to other serverless environments, as we need to on other cloud providers, whether private or public cloud, typically is going to be a bit science fiction at this point. So you're walking down the aisle with a particular serverless provider. In other words, it's possible to migrate the applications from one platform to the other. I always say with enough time and money, anything's possible, but it's typically not practical or cost effective to do so. So that's where people kind of miss the boat on leveraging serverless stuff if they're looking for portability. We do have containers that do cost additional money to build, and they take more time and energy to deploy. Those will provide you with portability and also performance. Serverless typically is not where you go for portability. So it's going to be where we're going to lock in the particular application to a particular platform, and we're willing to do that for a long period of time without necessarily migrating off the platform. So it's a fit typically when it's a net new application. It's difficult to port things to serverless, although you can do it. Value for scaling. So in other words, if I have an elastic application like a retail application that may go from 1,000 users in August to 100,000 users in December that are on this thing at a particular time, this is going to be an extremely nice way to do it because we're not having to deal with automatically trying to work ahead of capacity. Typically service-oriented, deals a lot with functions. And if you've built service-oriented applications in the past, remember SOA back in the day, and now SOA is dead, now it's alive again and living well in the cloud, and this is where you find it. And so the ability to write these functions, the ability to leverage these APIs, the ability to integrate these various services such as identity access management and governance platforms and API management and things like that into this is something that's typically going to be a great fit. So if I'm exposing APIs, I'm exposing information out of my infrastructure, using a managed API-based service that I'm charging for, serverless typically going to be a way to go. If you have an unknown user base, in other words, we don't know how much the user base is going to be from day to day, it's not predictable, this is a way to go. And then just consider the trade-offs. Not a fit for legacy applications. Sorry guys, your COBOL applications have to stay where they are. And chances are we're probably not going to have too many analogs for them to live in the cloud. We are going to have managed service providers that do work with clouds that you're able to leverage. So if you're looking for places for these older systems and you're trying to get out of the data center business. So look to the managed service providers. There's hundreds of them out there to take that technology. Typically it's not going to be for serverless. No value in scaling. Talked about the tire plant in Ohio, which is a real, which is a past client of mine. They had 100 people working in the factory 20 years ago, 10 years ago, 5 years ago, and they have no plan on expanding. And so, therefore, there's no need to scale. And also more traditional cultures within the organization. So they maybe leverage SaaS. They may be leveraging some aspects of infrastructure as a service, but if they don't have a DevOps culture, a DevSecOps culture, the ability to think innovatively, the ability to change quickly, the ability to have value of failing fast, which is why I showed you the slides before, this typically isn't going to be someplace you want to go. So there's a kind of a managed by magazine culture out there. It's probably managed by website now, where we kind of chased the shiny objects. This is one of the shiny objects that's out there. It's very tempting for organizations to start moving in this direction, but there's lots of reasons why they shouldn't move. And if you're, these are just basically 3 of them here, but you can think about 50 of them and how to do it. Cultural limitations, language limitations, porting limitations, security, compliance issues, PII information management, all that stuff has to be checked in with a particular technology before you start moving in this direction. So take this example. We have an as-is system, old system, monolithic, server intensive, difficult to update, maintain, and the feature requests. We have registration service. We have a I will vote service. We have a voter laws API. We have a registration database and an I will vote system. So let's turn this into a serverless. It's probably a pretty good example. So the 2B is we split out server functionality, voter registration processing using serverless technology. And so basically we start encapsulating some of these things as functions, and they basically exist in the serverless system as functions. And therefore they're in the isolated domain of the serverless system, able to scale up, we're able to leverage the technology we're able to leverage. So registration database, show you the previous one. That stays static. We have the I Will Vote system. We have an I Will Vote service and a registration service. We just basically make this thing in a service-oriented way and move aspects of it to the serverless system, typically with the code snippets from the existing traditional systems. And by the way, assuming the traditional system is using a language that we can leverage within the serverless environment. And serverless environments are typically polyglot, so we can leverage most languages within them. So this is typically how we do it. Now, one of the things you should notice, this is pretty simple, that's pretty complex. So we have more moving parts, more management, more ops characteristics, more points of management we have to deal with. However, we have the value of going to serverless. This is probably easy to understand, easy to operate. This is more difficult to operate, more difficult to build because we're building a complex service-oriented distributed system, in this case leveraging serverless technology. So working with AWS Lambda, that's probably the prevalent piece of software out there that's doing serverless. If you're an AWS user, I'm sure you've heard of it. And now with reInvent coming, like I said, in 2 weeks, we're probably going to go serverless other things as well. We already have databases out there that are serverless, but we can expect to see much more stuff. So we have an event source. Basically, it triggers a function and basically goes out into a serverless environment. It's able to carry out the function, and then it's done. So the idea is that we're not necessarily reinventing the wheel in how we're building a function or building a service, but it exists within a serverless platform. So unto itself, it runs itself, leverages the infrastructure it needs, the processing, the storage that it needs, and returns back as a successful function or has an bend error moving forward. So basically has to be an event that's kicked off, and this is typically the way it is within the other serverless systems as well. It's event-oriented or event-driven, so it could be time of day, press a button, piece of data shows up, a bit is flipped, whatever. And then it invokes a function that exists within a serverless system, which is able to leverage the infrastructure of the serverless system. So when you write these things, it's not service-oriented as an option. It's pretty much the only option how you build these things. So if you've done service-oriented development and built services and functions and APIs, this should be old hat for you. If you built structured programming environment, object-oriented programming environments, things like that, and not used an event-driven service-based environment, this is going to be a bit of a stretch. You're going to have to learn that first before you're good at architecting these systems. And by the way, you need to be good at architecting these things as well as building them, because that's kind of where the rubber meets the road. It's easy to build these things and write the functions within them. If you're a good programmer, you can certainly write a function, and they're basically little mini services that run within these environments. But your ability to build the architecture, define the architecture, is really where the winning thing comes. So you have to have it's very much like container-based computing. So it's not enough for me to throw something in a container and then run it inside a container, just like it's not enough for me to throw a program into a function and run it in a serverless environment. I have to be able to understand the architectural components to take advantage of what this technology is able to do. So we are going to have specialized people, and kind of this is where the career aspect comes in, who understand how to build and deploy serverless, and those are going to be very sought out technology skills to have. And so if you want a good job, you want to start making some major money, then get ahead of this. Even though serverless is already out there, get the training you need, understand how you do the development, but more importantly, understand the differences in how to deploy in a serverless environment versus a traditional environment, and how to design these systems and some of the best practices for designing these systems. And also understand that this is a complex distributed system at the end of the day. We saw this, that's more complex than that, and that's typically, imagine this, take this out to, 10,000 functions. We may take, 100 function points that exist within a traditional environment, and we could break that out to 5,000 functions that exist in the serverless environment. So we are making more things complex, more efficient, more scalable, better to run, live longer and have a long sustained life and more maintainable, but more complex, therefore difficult to operate, difficult to program. So and here's the steps in AWS Lambda. It's not an AWS Lambda class, so I'm not going to go into them, but understand the features of Lambda, understand how to build the application. That's what I recommend. Use best coding standards to carry out the plan, test the environment, deploy the environment, and operate the environment. And typically this is going to be part of a larger DevOps process where we're able to line these systems into a DevOps tool chain. We just leverage serverless technology as the deployment mechanisms for doing this, but continuous testing, continuous integration, continuous improvement, all those things basically build inside it. This is just another enabling technology for building something. So not much changes there. So I'm going to have 10 minutes for questions. If not, you guys have any questions that are coming up? George, you got one in the front? Keeping George on his toes.
We have a question. I have to get away from the speaker. Not you, that speaker. Oh. There we go.
Two questions which may be related. One, is it fair to say that the idea of on-premises serverless is an oxymoron?
Yeah, I don't think there's anything on-premise that would run serverless, other than the fact that Microsoft Stack is out there now, and so that runs on-premise, and that's something to look at. They may have a serverless deployment in that, but I'm unsure if it exists in there yet.
Okay. And in the example you gave with the voter application, the database you said remained static. So
yeah.
I would assume that there are probably a lot of applications where the middle tier is put into a serverless environment and the database remains where it was, which could mean that the middle tier is off at AWS and the database remains on premise.
That you can do that, but the trouble there would be the latency of the database being on premise, especially if you're using the open internet.
And also the charges for data egress, right?
That's right. It's charges for data egress. But there's people, I've seen people do it, and they do it successfully. As long as you're not pushing a lot of data across that pipe, you'll be okay. But also consider the charges, which you just brought up. Yeah. There could be more money to be saved in leveraging the data from the on-premise systems and information flowing in and out of the AWS platform.
Here we go.
Hi, David. This is Sarjeet. Quick question. Do you think that we will use the serverless in conjunction with the containers or VMs? Or do you think we can build just purely serverless applications?
I think we will see them with containers, and I think you'll see some huge announcements. There's already been some buzz about it right now. So I haven't gotten the updates from the bigger cloud providers out there, but you are going to see container-based serverless systems, the combining of the two, with some of the announcements that are coming from the larger cloud providers. And I can't speculate any more than that.
Just another aspect from the programmer's point of view, from the developer's point of view, doesn't it make like development messy in a way that you are dealing with extra isolated functions and you're trying to glue it together as compared to our traditional development methods?
If messy means complex, yes it is. It's going to make things more complex.
There you go. Are there other questions? Here we go. Sorry.
Thank you. Hello, David. I have a question which is in line with cloud computing. I know that there has always been debates about was cloud actually a good misnomer to actually represent cloud computing as a technology. Being said that, I believe there has been a shift in the industry in the last 2 years that cloud have started being equating to public cloud. Is that actually appropriate or accurate, or is cloud computing is actually the technology that lies underneath?
I think it's one of these semantics that's overloaded with whatever it is. I mean, now it's public, private, now it kind of means AWS and anything that's public cloud to the point you just made. I wrote a blog, I think 6 years ago. If cloud computing means everything, it means nothing. And I kind of view that. But, I'm going to be obedient to my robot overlords and continue to use that semantically, or else you're kind of punished for it. But you're still looking at, we're redefining it all the time. I agree, it's kind of an odd buzzword. I think it's going to kind of bake into computing as we go forward. But, I have the same sort of challenges going forward. Because the first thing you have to do is get the semantics correct when you talk to somebody. What does hybrid computing mean? Well, it used to mean private and public cloud paired. Now it means legacy and public cloud paired. What about multi-cloud? Does it include private cloud? Well, sometimes it does. According to some people, sometimes it doesn't. What about governance? Well, it used to be an API governance as well as resource governance. Now it can be everything that deals with. So we get into a semantic issue when you have, $40 billion in marketing that's out there chasing cloud computing. Everybody's defining it their own way. And typically the people with sense don't have a PR agency. And so that's kind of the way it's working out.
I love ambiguity and confusion because it means there will always be a need for trade shows and there will always be a need for analysts and writers and research.
This is related to the voter registration example, and also the claim by some that the cloud should reduce cybersecurity risk because cloud providers are constantly updating the programs, and you don't have the same vulnerabilities that you have with legacy systems. But with this more complicated structure, does that negate the claim that the cloud is safer?
Yeah, good news, bad news, and we're going to go ahead and make that the last question. So if you guys want to come up and talk to me after that, that's fine. But I'll answer your question. Good news, bad news is that security is typically going to be harder if you're making the thing more complex, or as he says, messy, which I probably like better than complex. It's more apt. So you have more things to secure, more ways in which people can do an attack vector on the system. Security can be problematic the more you distribute it in making the systems. That's number one. However, the good news is that 75% of the R&D dollars, best I can tell, are going into cloud-based security and not necessarily on-premise-based security. So if you want the cool new stuff to protect your systems, even though you're building complex distributed systems, they're typically going to have better technology in the cloud than they are on-premise, going forward if you follow the patterns. So there's a blog I did in InfoWorld a couple weeks back called The Forced March to Cloud Computing, where I looked at this. In other words, the research and development dollars within the security companies are all moving to the public cloud providers, basically to provide security in there, whether they're a part of it or not. And so the on-premise systems, by default, are not going to receive as much R&D dollars because it's a zero-sum game, and therefore they're going to be more exposed. So even though we're building more complex distributed systems on the cloud using functions and serverless computing and component-based computing, things like that, in my estimation, they should be more secure just because we're paying more attention to that side of the architecture. That's it, guys. Have a good conference.
All right, thank you. So everything you knew about